Hi everyone, myself Dr. P. Soumya, working as an assistant professor in the Department of Chemistry, Institute of Aeronautical Engineering. In this session, I am going to discuss about biomagnification. So here are the topics: introduction to biomagnification, and bioaccumulants. So differences between bioaccumulation and biomagnification, persistent pollutant versus short-lived pollutant, and causes and effects of biomagnifications. Biomagnification due to diphenyl trichloroethane, that is DDT, and bioconcentration definition, bioconcentration factor, and mercury levels in fish across the West Bengal. How to control biomagnification and preventive measures. So, introduction to biomagnification. It is also known as bioamplification and biological magnification. Biomagnification, it is also known as bioamplification and biological magnification. So, what is the meaning of biomagnification? Means it is the increase in concentration of pollutant. Biomagnification, it is increase in concentration of pollutant that occurs in a food chain. So here it is increasing concentration of pollutant that occurs in food chain. So here it is a consequence of persistence bioenergetics in the food chain and low rate of internal degradation or excretion of substance, often due to water insolubility. So these are the consequences of biomagnification. So these are due to persistence and bioenergetics in food chain, low rate of internal degradation or excretion of the substance, often due to water insolubility. So what is the biomagnification means? It is also known as bioamplification and biological magnification. So it is the increase in concentration of pollutant so that occurs in a food chain. So biomagnification, it occurs when substance such as pesticide or heavy metals, pesticides or fertilizers or heavy metals move up the food chain by working their way into environment. So biomagnification, it occurs when the substances, so such as pesticides, fertilizers, or heavy metals, or any pollutants that move up the food chain by working their way into environment. Example of this biomagnification is pollutants in river or lakes. Pollutants in a river or lakes. So these are taken up by the microorganisms like plankton and are eaten by the aquatic organisms such as fish, which is in turn are eaten by large birds or animals or humans. So the substances become concentrated in tissues or internal organs as they move up the chain. So if we see the lake or river, if it is having pollutants in rivers and lakes, these pollutants are taken by the microorganisms. So then these microorganisms, so these are consumed by aquatic organisms, any aquatic organisms like fish. So these fish, small fishes are consumed by medium fishes. Medium fishes are consumed by large fishes. These fishes are consumed or eaten by the birds. These are eaten by the birds as well as humans as well as animals. So if we see this flow chart, so the pollutants, these are moving from one trophic level to another trophic level, like microorganisms to human or birds or animals. So here the substances, these are become concentrated in tissues or internal organs as they move up the chain. So means the higher concentration is present in higher up that is in the food chain, like human or birds or animals. So as a result, the organisms at the top of the food chain. So as a result, so the organisms at the top of the food chain generally suffer greater harm. Generally suffer greater harm uh, from the persistent toxin or pollutant than those at lower levels. Why? Because so here at each level, the food chain is there. There is a lot of energy loss. At each level of food chain, there is a lot of energy loss. A predator must consume many prey. The predator that must consume many prey. So here, including all of their lipophilic substances and fats, which carries the pollutant, which then accumulates in fats of the predator. So that's why the concentration of pollutants is more in higher up that the higher up, which is the top of the food chain, because the predator, it will consume many prey. So means if it is consuming more prey, so here the prey are carrying each prey, so these are carrying pollutant and toxins. So as that is consuming, the predator is consuming many prey, so it is the concentration of pollutants are more in predator than prey. So as a result, so the organisms at the top of the food chain, so these are having greater harm. These are having greater harm. So from the persistent toxin or pollutant than those at lower levels. So this is the biomagnification, that is of methyl mercury. So here methyl mercury bioaccumulation in organisms. So this diagram shows methyl mercury bioaccumulation in organisms. So if we see the diagram, so here the biomagnification of methyl mercury, it is increasing from lower level to higher level, some lower level to top level. So if we see this if we see this methyl mercury pollutants, so these are first consumed by so some aquatic microorganisms or any some herbivores. So these are consumed by producers. So these producers, these are consumed by small fishes. These small fishes are consumed by large fishes. So finally, these large fishes, so these are consumed by predators like humans, animals, and birds. So if we see this diagram, the concentration of methyl mercury, it is increasing from bottom to top. So here this is the biomagnification of methyl mercury in aquatic life. So biomagnification, it occur in almost all types of ecosystems, like terrestrial ecosystem, aquatic ecosystem, and marine ecosystem. So if we see this diagram, it is showing biomagnification. So when contaminants increase at each step of the food chain, these when these are contaminants increase at each step of food chain. How the contaminants are increasing in each step of food chain. So this is the biomagnification of some toxins. If we see the producers, so here this is this is the producers. These are the producers. So these are producers. We have primary consumers and secondary consumers, tertiary consumers. So if we see the contaminants, concentration of contaminants in producers, so that is 0.04 ppm. The contaminants present in producers, so these the concentration is 0.04 ppm. So for primary consumers, so this is 0.23 ppm. So as these primary consumers are consumed by secondary consumers, the concentration of toxins in secondary consumers is 2.07 ppm. So whereas for tertiary consumers, the contaminants concentration is 13.8 ppm. If we see the concentration of contaminants, so it is increasing from the bottom to top, from the producers to tertiary consumers. So this is so here. So we can see the concentration of the contaminants is more in top level of food chain. Top level of food chain. So what are bioaccumulants? And what is the differences between bioaccumulation and biomagnification? Bioaccumulants, these are toxic substances. Bioaccumulants, these are toxic substances that increase in concentration, in tissues of living organisms. So bioaccumulants, these are toxic substances, these are pollutants that increase in concentration in tissues of organisms, living organisms. So they enter the organisms through contaminated air, contaminated water or food, so which and are very slowly metabolized or excreted. So bioaccumulants, these are the toxic substances that increase in concentration in the tissues of all living organisms. So these bioaccumulants enter the organisms through contaminated air or contaminated water, contaminated food, and these are very slowly metabolized and these are very slowly excreted. So what is the differences between bioaccumulation and biomagnification? Bioaccumulation, it is the concentration of pollutant. Bioaccumulation, it is the concentration of pollutant from the environment which occurs within a trophic level. Bioaccumulation, it is the concentration of pollutant from the environment which occurs within a trophic level. So that is one level of food chain. One level of a food chain, it is usually the first organism in the food chain. So bioaccumulation means it is the concentration of pollutant in one trophic level. Concentration of pollutant in one trophic level during time. So here, whereas the biomagnification, it is the concentration of pollutant across the food chain. So bioaccumulation, it is the concentration of one trophic level, concentration of pollutant in one trophic level. So whereas biomagnification, it is the concentration of pollutant across the food chain, how it is increasing. So that is the biomagnification. So the difference between bioaccumulation and biomagnification. So this picture clearly shows the differences between bioaccumulation and biomagnification. If we see the first diagram in bioaccumulation, biomagnification, so this first image, it clearly shows about bioaccumulation. If we see the fishes here, small fishes are becoming big fishes. So as time increasing, these are becoming big fishes. So as these are becoming uh, big fishes, the concentration of the blue color, it indicates contaminants levels. The concentration of, as they're becoming bigger, so these the concentration of contaminants are increasing. So this is known as bioaccumulation. So this is the concentration of pollutant in one trophic level during time. So during one certain time. So here biomagnification means this is the concentration of the pollutant, so across the food chain. So if we see this diagram, this is in this, these are some microorganisms or small, some producers. So these are consumed by small fishes. These small fishes are consumed by big fishes, and these are consumed by animals. So if we see this diagram, so the concept, if you see the color of the contaminants, the blue color, it indicates the contaminant level. So if we see this diagram, the contaminants concentration is increasing across the food chain. So this is biomagnification. Bioaccumulation is the concentration of pollutant in one trophic level. Biomagnification, it is the concentration of pollutant. It is across the food chain. So this image, we have here 5 steps. This is the aquatic system. So if we see this, so there are many ways. So here I have So we have shown one lake system. So that is, there are many ways to chemicals end up in lakes and rivers, including wind or runoff. So here for this lake, it will get many contaminants from the runoff or wind or other any other pollutants, any other way. So second step, it is the chemical sink to the bottom of the lake or river, where they settle in the sediment. So river, it is getting chemicals or pollutants from different ways, and these chemicals which are getting from different ways, these are accumulated or these are deposited at the bottom of the lake. So that is called as chemical sink. So in third step, the small creatures, these are called as micro invertebrates. So chemicals. These eat chemicals as they dig in the sediment for food. So as they digging for food in the sediments, they will eat the contaminants. They will eat the chemicals. So, as in fourth step, the macro invertebrates, the small creatures, these are eaten by minnows. So these are medium-sized fishes. Minnows, and after that, these are eaten by the medium-sized small fishes and medium-sized fishes, then large fishes. So large fishes. So here each step. So here small fishes, it is collecting contaminants, and medium fish, it is also collecting contaminants, and large fish, it is also collecting contaminants from the medium fishes. Means these are getting more concentrated contaminants into their bodies. So in fifth step, this is why larger fishes and predator fish and longer living fish are likely to have more chemicals in the bodies than smaller and younger fish. So this is biomagnification in the lakes. So if we are concerned about these phenomena, because together they mean that even small concentration of chemicals in the environment, they can find their way into organisms in high enough dosages to cause problems of predators. So biomagnification. So here, in order for biomagnification to occur, the pollutant must be long-lived, mobile. It must be mobile, and it must be soluble in fats and biologically active. So what is the qualities of pollutant? What is the in order for biomagnification to occur, the pollutant must have, it should be long lived. It should be mobile, and it should be soluble in fats, and it should be biologically active compound. So this diagram indicates the persistent chemicals in action. This is one example. So in 1970, a factory puts out a lot of persistent chemicals, lot of toxic chemicals, lot of long-lived chemicals through its smoke stacks. So through its air. So here the lake which is showing in this diagram, this is contaminated by air. So in 1970, the factory puts out a lot of persistent chemicals through its smokestacks. So in 2011, the factory has a pollution control devices on its smokestacks. But the chemicals put out in the past years still remain behind, because this meaning. So the pollutant, the persistence, these are long lived. These are having long life. So that's why. So here these are causing the biomagnification. Biomagnification. So, what is persistent pollutant and what is short-lived pollutant? So, what are the differences between persistent pollutant and short-lived pollutant? So, here pollutants that dissolve in fats are retained for long time. The pollutants which dissolve in fats and these are retained for long time, they are called as persistent pollutants. So these are long-lived pollutants. Lipid or fat-soluble substances cannot be diluted. The lipid or fat soluble substances cannot be diluted and cannot be broken down and cannot be excreted in urine. So they accumulate in fatty tissues of organisms if the organism lacks enzymes to degrade them. So what is short-lived pollutant? So if pollutant it is short-lived, it will be broke down easily. It will broke down before it become dangerous. So here, if it is not mobile, it will stay in one place and it is unlikely to be taken out by organisms. So if the pollutant is soluble in water, it will be excreted by the organism. If the pollutant it is soluble in water, it will be excreted by the organism also. There is no harm by the short-lived pollutant. So here there is very harm. So by the persistent pollutant, that is long-lived pollutant. So what are the causes of biomagnification? So we have many causes. So here by using uses of agricultural products, organic contaminants. So due to plastic pollution, due to mining, and due to toxic gases and air pollution. So these are some of the causes of biomagnification. In agriculture products, chemicals from herbicides, pesticides, fertilizers, and so these are accumulate in the soil and water bodies, eventually reaching the organisms through consumption. So we know that the chemicals, so herbicides, pesticides, fertilizers, these are having chemicals. So these are some toxic chemicals. These are accumulated in the soil or water bodies. So eventually these are consumed by the other living organisms. So organic contaminants, these harmful substances released from the organic substances. So contaminants, these are released from organic substances like manures and biosolids, and these are enter the food chain. So plastic pollution, due to plastic pollution, so the disposed plastic waste, so this particularly microplastics, these release harmful chemicals that accumulate in aquatic organisms. And also due to mining, mineral deposits released during mining activities can contaminate water bodies affecting aquatic as well as farm animals. So due to toxic gases and air pollution, gases released into environment can dissolve in rainwater, eventually accumulating in the food chain. So these are some of the causes of biomagnification using the agriculture products, chemicals, and which are from the herbicides, pesticides, and fertilizers, organic compounds which are produced from the organic substances like manures and biosolids, and plastic pollution. So disposed plastic waste like microplastics, these will release harmful chemicals into the environment, and also mining, mineral deposits, these will release some contaminants into water bodies. So next, toxic gases and air pollution. Gases released into environment, these can dissolve in rainwater. So these are eventually all the pollutants, all the contaminants present in environment, these will accumulate in the food chain. Effects of biomagnification. So it will affect many health, human health, and it will affect aquatic animals. So what is the effect of disruption of food chain? Destruction of coral reefs. It will affect the microplastics and biomagnification. So human health, consumption of contaminated seafood and plants. This can lead to serious health issues, including cancer as well as organ damage. So human health, so it will affect my human health. So due to consumption of contaminated seafood and plants, that can lead to serious health problems, health issues, and including cancer also, and also organ damage. So aquatic animals, accumulation of metals in marine organisms affects their development, reproduction, and eggshell thickness. Disruption of food chain. Accumulation of toxins disrupts the natural food chains, leading to ecological imbalances. And also destruction of coral reefs. Toxin like cyanide from gold leaching and fishing contribute to coral reef destruction. Microplastics and biomagnification. Microplastic contamination affects marine organisms with potential risks for human health through consumption of contaminated seafood. These are the some effects of biomagnification. So this is the biomagnification due to DDT. So DDT full form is a dichloro dichloro diphenyl trichloroethane trichloroethane. This is used as insecticide in the 40s and 50s and 60s. So this DDT entered into the environment in runoff from the land. So DDT, it was banned in 1972 after the bald eagle population had a noticeable crash. So it was banned in 1972 after bald eagle population had a noticeable crash. So the structure of DDT is diphenyl trichloroethane. So we know that this is a pesticide. So this is a chlorinated hydrocarbon. It is used as a pesticide. So this diagram, this is table shows the half-life DDT half-life in 15 years. So here the 15 years, which means if you the half-life of DDT is 15 years, which means if you use 100 kg of DDT, it will break down as as follows as shown in the table. So the half-life of DDT is 15 years. If we see the table, so each for each 15 years, the concentration of DDT it is decreasing to half. So in 0 year it is 100 kg. After 15 years it is becoming half, like 50. After 30 years, so it is becoming again half, like in 50 it is half means 25. Like that after 120 years it is becoming 0.39 kg. So means it is taking more years to break down. It is more years break down. More years time is taking for the breakdown of DDT. So even though after 120 years, so the remaining DDT is 0.39 kg. So if we see this diagram, so here this is the magnification of DDT concentration. So here first this is the aquatic system. So in water, so that is having 1 ppm. So this is having 1 ppm concentration. So here the producer are phytoplankton. This is consuming from the plants. Consuming the plants are these are getting contaminants from the water. So these producers are consumed by zooplankton. So these are getting contaminants from phytoplankton. So these plankton, these are consumed by small fish. Small fish are consumed by large fish, and large fishes are consumed by fish eating birds. So if we see the diagram, if we see the concentration increasing concentration of DDT. So here if we see this in water it is having, if it is in ppm, so if it is 1 ppm, so after that in producer stage it is 1000 ppm. So here 10,000, so 1 lakh, so like that it is increasing, like that it is increasing 10 times. So 10 times. So here the concentration of DDT it is increasing from lower level to top level, from producer level to top level. So DDT it is known to disrupt calcium metabolism in birds. So DDT, that is dichloro or diphenyl trichloroethane, it is known to disrupt calcium metabolism in birds. So it is a crucial process for the formation of eggshell. The eggshell it is formed by the calcium. So but DDT it is disrupting the calcium metabolism in birds. So it is a crucial process for formation of eggshells. In the interference with calcium metabolism, it results in the thinning of eggshells. The interference of interference with the calcium metabolism, it results in thinning of eggshells, this making them fragile and prone to premature breaking. So they are making fragile and these are prone to premature breaking. So this in turn lead to reduced reproductive success and decline in bird population. So here that's why the DDT it is decreasing the bird population. So because it is disrupting the calcium metabolism in birds, so the calcium metabolism, the interference with the calcium metabolism, it is resulting thinning of eggshells. So these are making them fragile and these are prone to premature breaking. So because of that, the reproductive success rate of birds it is decreasing, and the accumulation of DDT and its breakdown products in fatty tissues of these birds contribute to the process, as the toxins are concentrated and impact the bird's health, reproductive abilities. So these DDT, these are accumulation of DDT. So it is breakdown. Its breakdown products in fatty tissues of birds. These are contributing health issues and also so these are reducing the reproductive abilities of the birds. So the impact of DDT on bird population, particularly raptors like eagles and falcons, was a significant driver behind the environmental movement and the push for regulations on the use of such persistent pesticides. So this example serves as a reminder of an intricate relationship between pollutants, ecosystem, and species within them. So as this is the reason what is DDT? It is disrupting the calcium metabolism in birds. That's why the finally the birds this is reduced because of this. The DDT it is reducing the reproductive abilities of the birds. That's why the population of bird populations are decreasing. So these are some of the pollutants and these are some of the uses and problems. So this table indicates some of the substances, some of the contaminants and their uses and how what problems we can get from the contaminants. First one is PCBs, polychlorinated biphenyls. So these are used as insulator in transformers. These are used as plasticizer, fire retardant and impairs reproduction. So what the problem means it will impair the reproduction. So polynuclear aromatic hydrocarbons, these are contaminants, these component. So these are uses of these are these will act as a component of petrochemical petroleum products. And the problem is these are very carcinogenic. And heavy metals like mercury, copper, cadmium, chromium, lead, nickel, zinc, tin. So these are used in mercury from gold mining, and mercury is used for gold mining and many from metal processing. Many metals, other metal, heavy metals are used for metal processing. So these heavy metals, these will affect the nervous system, affect reproduction. And cyanide, this is also one of the most dangerous pollutant. It is used in leaching gold and it is used in fishing and it is very toxic in nature. Selenium, it is concentrated by forming desert soils, reproductive failures, and it is toxic in nature. So these are some of the substances, some of the contaminants and their uses and problems. So how to measure the pollutants? To measure the pollutants, so the amount of pollutants in it is measured in fatty tissues of organisms such as fish. So they have for the measuring of pollutants. So here these are in fatty tissues of organisms. In for the measuring of pollutants in fish, so we have to take fatty tissues from the fish. So in mammals, we often test the milk. Milk. So to measure the pollutants in fishes, we have to take the fatty tissues. So in mammals, we oftenly taken milk of the mammals. Bioconcentration. So this is what is bioconcentration means. Bioconcentration, it is term used specifically in reference to aquatic environments and aquatic organisms. So this is specifically it is used for aquatic environments and aquatic organisms in contrast with related bioaccumulation. So it is also related to bioaccumulation, so which can refer to toxins and organisms found in a variety of environment. So this is also referred to toxins, amount of toxins and organisms found in variety of environment. So here the substance, so the bioconcentration, it is a substance or a pollutant. It can also be taken up by the organism from the surrounding water by non-dietary routes. By non-dietary routes. So bioconcentration, it is a substance or a pollutant. It can also be taken by the organism from the surrounding water. From the surrounding water. Example of this bioconcentration, it is through the gills of a fish, through the gills of a fish which travels the water through the gills of a fish which travels through the blood to the lipid tissue. So this is bioconcentration. What is bioconcentration means? It is substance or a pollutant. It can also be taken by the organism from surrounding water by non-dietary routes. So how to measure, how can be expressed bioconcentration factor? It can be expressed as the ratio of the concentration of chemical in an organism to the concentration of the chemical in the surrounding environment. So here the ratio of concentration of a chemical in organism to the concentration of the chemical in the surrounding water. This is nothing but bioconcentration factor. So the it can also be defined as the rate of substance uptake to the rate of substance elimination. So it can also be defined as the bioconcentration factor. It also can be defined as rate of substance uptake to the rate of substance elimination. So this is the diagram shows fish accumulation processes. So here this is the bioaccumulation factor. So here uptake from food, loss of digestion, growth dilution, so loss of metabolism, loss via gills, uptake via gills. So here if we see this uptake via, it is taking water from uptake, it is via gills and also it is from the food. So it is losing via gills and loss by digestion, and it is used for growth dilution, loss by metabolism. So bioconcentration it factor, it is defined as the rate of substance uptake, rate of substance elimination. So the if the bioconcentration factor, so if the higher the ratio, the more severe is the bioconcentration. It is the higher the ratio, the more severe the bioconcentration. As a high BCF, it can lead to health problems such as genetic mutation passed to the offsprings. So in fish populations, increasing number of fish spawn with ambiguous genitalia, genitalia so have been identified in waterways contaminated with pharmaceuticals. So some of the effects of bioaccumulation on humans. So here proteins, omega-3 fatty acid, and it is pros of fishes. So here bioaccumulation of humans. So here it is fishes. It is having proteins. These are having omega-3 fatty acids, vitamin B. It is rich in vitamin B, relatively low in fat, good for the heart and bones. So here cons are this is having some mercury impurities. So here fishing methods, some cons are fishing methods are different and farming methods are difficult. So here cons, main con is mercury. It contains some low level of mercury. So mercury levels in fish across West Bengal. So here alarming level of toxic mercury were found in 264 samples of popular fish like rohu, bola, tangra or betki and other fish varieties. So collected across the West Bengal. So here, so the trend is applicable across the country. So while 52 cases had mercury concentrates in excess of Prevention of Food Adulteration Act, so standards of 0.5 ppm, and 129 of fish showed methyl mercury levels. So a metabolized and more poisonous form of mercury exceeding 0.25 ppm PFS stipulations. So this is the mercury levels fish across the Western Bengal. So, what are the causes of mercury levels rise in the fish level? So, here it is using during the coal firing due to mining and thermal plants use, and it is from industrial effluent directly discharged into the water bodies and municipal wastewater streams. So, what are the causes of high level of mercury? Uh, Mercury. So here it will cause the neurotoxicity and impairs motor skills and stands for psychological development and growth, and it can cause serious mental disorders over a gradual period of time. So biodiversity research institute in Maine August 2013 estimated that 83% of fish worldwide have unsafe mercury levels. Over 50% of Asian population have more than 5 milligram per ml mercury level impaired. Cause for global concern because most seafood it is imported and exported. Pollution it is worldwide problem. It requires cooperation of various nations. Example, pollution of ocean and seas. So, how to control biomagnification? Do not put harmful substances into the water systems or storm drains, and avoid toxic chemical pesticides, and eat certified organic foods when possible, and avoid fishing or spending time in contaminated areas. So, what are the preventive methods for biomagnification? So, eliminating heavy metals at source, prohibit and eliminate toxic substances from industrial products and process, and using cleaning contaminated areas. Identify the clean areas contaminated with the toxins, implementing waste reduction programs, and regulation and awareness. Implement regulation against toxic substances, promote alternatives, and raise awareness, and also using strengthening monitoring. Expand real-time water quality monitoring network and promote self-monitoring mechanisms, and also using waste management. Enhance waste management rules and technological solutions to reduce toxic substance release. So these are the some of the preventive measures. So by eliminating heavy metals at source, cleaning contaminated areas, regulation of and awareness, strengthening the monitoring, and also using waste management, we can prevent the biomagnification at some extent. So this is about biomagnification and preventive and how to control the biomagnification. And thank you.
Like, share, and subscribe. Hit the bell icon for more updates.